very similar to what we saw with the product rule, we can also look at the quotient rule through other means. We can look at it graphically if we look at some functions. So let's let this red line right here be the function f of x, and we'll let this blue linear piece be g of x. This is actually the same graph from our topic 2.8 lesson. And let's let h of x, since we're talking about the quotient rule here, let's let it be f of x over g of x. And what we want to do is we want to find h prime of 2. And this kind of question right here is very, very popular for your AP exam, either given to you graphically or from a table. Well, if I want to know h prime of 2, again, I need to take h prime of x. And that's going to be a pretty straight execution of the quotient rule. So I'll start off with low d high minus high d low. And so there's my notation for when I was taking the derivative all over low squared. And so if there's h prime of x, if I want to know h prime of 2, well, h prime of 2 is simply going to be g of 2 f prime of 2 minus f of 2 g prime of 2 all over g of 2 quantity squared. And just like we saw in the previous topic with the product rule, I need to now go find these values. I need to know f of 2 and f prime of 2, as well as g of 2 and g prime of 2. And in fact, I'll be using g of 2 twice. So let's go look at these on the graph and remind ourselves how to identify these and what the notation is really expressing. So f of 2 and g of 2 are simply asking, what is the function value at 2? For f, that's going to refer to this point here at 2 comma 4. So f of 2 is equal to 4, while g of 2 is going to refer to this point right here at 2 comma 1. So g of 2 is equal to 1. Now when I look for f prime of 2 and I look for g prime of 2, remember that those are referring to the rates of change. That's what a derivative means. So this notation right here, f prime of 2, means what is the rate of change of f at 2? And again, because f is this linear piece, its rate of change is constant. And if you just do some rise over run, you can see f prime of 2 is equal to 1. While g prime of 2, it's a little bit steeper. It has a rate of change of 2, or a rise over run, or slope of 2, since it's a linear function. So now I can go back and substitute these in and say h prime of 2 is equal to, all right, g of 2 is 1, f prime of 2 is 1, minus f of 2, which is 4, g prime of 2, which is 2, and it's all over g of 2, which was 1, squared. And so if I do the computation on this, the denominator there is going to be equal to 1, and this ends up being 1 minus 8, and so h prime of 2 is equal to negative 7. So just like we saw in the previous topic with the product rule, we can apply this same logic from either a graph, or if we're given a table of function and derivative values, we can apply it that way too. And it's just pretty much a strict application of the quotient rule in this case.